Hello, my name is Nicholas Dorbin, and I'll be showing you a weapon called the Pointer, which I made for the Source engine. This video will be divided into two parts. The first will explain the weapon from the player's perspective, and the second will explain it from a developer's perspective. Please note that the weapon has no model at the time of the video, so placeholder models and animations are being used instead. The Pointer functions like a boomerang with some added features. It has a primary attack, a secondary attack, and a modifier called Overclock. Primary fire throws the pointer straight ahead, dealing damage to anything in its way and returning to the player when it hits a wall or until a set amount of time has passed. After it returns to the player, they may throw the pointer again. Secondary fire allows the player to select multiple targets for as long as they hold the button. The maximum number of targets selectable is 5. Upon release, the pointer will hit each enemy in order until all targets are dead or until it collides with the wall. Secondary fire has a short targeting range though, so the player will have to use the primary fire in order to hit enemies that are farther away. In addition to these two firing modes, there's another feature of this weapon which is a skill-based explosion upon successful execution of either the primary or the secondary fire, called overclocking. When the pointer hits 2 enemies in a row, the pointer enters the overclock state. When this happens, the pointer projectile moves faster, and all enemies hit will now catch on fire and explode in a small radius. When the projectile returns to the player, it is no longer in the overclock state. The overclock feature was added to reward the player with skill when they set up their shots correctly. Now to explain this from a developer's perspective. The pointer was made using the crossbow as a starting point. The crossbow fired a bolt which was affected by gravity. After it hit an enemy, it would destroy itself and pin the enemy to a wall. I chose to use the crossbow as a starting point because it was a weapon that created a physics-based projectile. The C++ file for the pointer contains the code for both the pointer weapon and the pointer's projectile. I will start explaining the weapon and then move on to the projectile. The weapon has functions for when primary and secondary fire keys are pressed but not held. In order to create the targeting feature, we make a call to the getTargets function at every frame to check if the key is being held. Calling getTargets at every frame does not cause slowdown, but a simple boolean in the secondary fire function can control the calling of getTargets if it needed to be optimized. If the secondary fire key is being held, then getTargets makes a trace line from the player. If we hit an NPC, we check that our entity list is not full, and that this entity isn't already on our list. If that passes, the entity is added to our list and the enemy is rendered in a blue color to show its targeted state. getTargets also checks once we've released the secondary fire key. If so, the weapon calls targetBolt, which fires a bolt and gives the bolt the entity list that was created. The reload function was changed since the player should not be allowed to throw a pointer until it has returned. To accomplish this, the reload is prevented from being called until the player holds at least 2 ammo for the weapon. The projectile adds ammo to the player and calls the weapon's reload function once the weapon returns to the player. Now we move on to the projectile's code. The projectile has a few different think and touch functions that are changed dependent on the state of the projectile. Touch functions handle the collisions of the projectile, and think functions are the update functions that are called at set times instead of every frame. The programmer can set when the next think is being called by calling next think and giving it the current time plus the interval in seconds. For bolt touch, which is our primary fire's touch function, if the projectile touches an NPC, we increment our enemy's hit counter and check to see if the overclock state is being set. If it is, we ignite the enemy and generate an explosion at the projectile's current location. If we hit a wall, the projectile is set to return think and return touch functions. At the end of our touch function, we check the enemy hit counter, and if we have hit enough enemies, we set the overclock to true and increase our velocity by our preset factor. In bubble think, the function that originally generated bubbles underwater, we check if the projectile needs to change states. If the entity list contains an entity, we change to our targeting mode. If we run out of flight time, we change to our return mode. In Target Think, we check that our current target is still valid and alive before we attempt to approach it. Then, using simple vector math, we get the direction the projectile must head by subtracting the enemy's position by the projectile's position. The enemy's position was raised by 40 units before the subtraction in order to aim for the enemy's chest instead of their feet. If the target is dead, we set the enemy's list position to null. If we are out of targets, the projectile switches to the return functions. Since we are targeting, the velocity has to be set at every think to follow our target as it moves. As such, the overclock velocity is also set in our target think function. Target touch is nearly identical to the bolt touch function. The only changes are the resetting of the target's color upon death and a check to return the bolt if there are no more targets to hit. For return think, we have a check for our no-clip time, which is set by return touch. If the projectile collides with an impassable object, we let the projectile no-clip for a certain amount of time, then return it to its normal fly state. We need the projectile to swap out of no-clip or it won't know if it reached the player. Using a similar algorithm for the target think, we get the player's position and subtract it from the projectile's position to get the direction the projectile must head. We then set the projectile's velocity towards the player. For return touch, we set the bolt to no-clip if we collided with a wall. If we haven't, we check the entities and arrays of the projectile. If one of them is the player, we give ammo to the player, set any remaining targets to their original color, signal a reload, and then remove the projectile from the game. That concludes the demo of my weapon. I hope you find that this video was informative. If you have any questions, please feel free to email me at nicholasdorban@gmail.com.